Okay, so in this problem, we're trying to express the following statement using predicates, quantifiers, and logical connectors. And the problem is every remote server is monitored by exactly two systems. Now, what I'm going to do is just to remove some ambiguity, I'm going to say by exactly the two, I'm just going to add the word exactly the two same systems. Okay, so let's think about this. One of the questions that I was asked during office hours is given the question, is there any way I can figure out how many domains am I playing with? So the question is every remote server, and this tells you that the first domain that I'm looking at is because I have the keyword every, I'm looking at the entire universe. I'm looking at the entire universe of all remote servers that are out there. So one domain that I'm playing with is a domain of remote servers. And then I'm looking at some kind of a quantifier. I'm looking at some kind of a quantifier that says exactly two systems. Now, I don't have anything in my toolkit at this time that allows me to express exactly two systems. I have the universal quantifier that tells you to, to map every single system. I have the existential quantifier that tells you that maps one or many systems. But how do I map exactly two systems? And we're going to do that right now. But again, coming back to my original question, I need some kind of a quantification even on the domain of systems. So what we're going to do here is I'm going to first draw the universe or the domain and the domain of, in this case, systems. Everything in purple over here is systems. And I'm going to draw the domain of remote servers. And just to visualize the problem a little bit, what this tells you is that for every remote server, so in this case, if I have, let's say, I have 1, 2, 3, 4, 5, 6, I have 6 remote servers. And let's say I've got 1, 2, 3, 4 systems. Every remote server is monitored by exactly the two same systems. So if I select in this case system A and system B, okay, if these are my two systems over here, system A is monitoring every single remote server, and system B is also monitoring every single remote server. But C and D are not monitoring any of the remote servers. Okay, think about this. Just if you want to visualize this again, let's just think about this. I have a remote server here, which is being monitored by B. This piece over here is also being monitored by B, being monitored by B, being monitored by B, and by B. And let's use a slightly different color. Let's use blue. So let's say this remote server is also being monitored by A, also being monitored by A, by A, by A, by A, and by A. Okay, kind of a funny diagram here, but you get the idea. You get the idea that every remote server is monitored by exactly the two same systems, and the two same systems are A and B. The moment you have one of these systems also monitoring a remote server, well, then this entire statement falls apart, right? It falls apart in this scenario. Okay, so how would I try to express it? How would I try to express something that makes it true, for exactly the two same systems monitoring every remote server? Okay, so what I'll do now is I'll use a slightly different color. Let's use I don't know, let's use yellow over here. And that says that for all systems S, okay, or let me not use S for systems here. Let me use, in fact, let me use S, that's fine. Let me use S again. But what I'm going to do now is I'm going to say for all remote servers, and that's what I'm using S for. Okay, S is being used for this domain of remote servers. For all remote servers, there exists some X and there exists some Y. Okay, and this order is really, really important. That's one of the things we looked at last week, which is for all remote servers, there exists some X and there exists some Y. Okay, there exists some X and some Y, but it's important that these X and Y are different. They cannot be the same thing. So let's add that constraint here. X does not equal to y. As long as x does not equal to y, and there's a predicate m that tells you that x is monitoring the remote server s, and x is monitoring s, and m, the same predicate m, which is y is also monitoring s. Okay, if I leave my problem the way it is right now, is this correct? Is this actually correct? Well, it is not entirely correct. It's not entirely correct in the sense that this does not guarantee that you have exactly the two same systems, because there could be another pair. There could be another pair that could also be monitoring the every single remote server. Because all I'm saying over here is, for all as there exists some x and there exists some y for which this entire piece becomes true. I just happen to choose x to be equal to a and x equals to b. That makes it true. But there could be some another pair that also makes it true, which means that if that pair exists, or if even one such system exists, then you don't have exactly the two same systems. There is more than two. And because there's more than two, it will also make this entire statement in yellow true. Okay, so if my feasible region over here can accommodate more than two systems, I have to constrain it. I have to constrain it and limit my feasible region to a point where it only has exactly the two same systems. And how do I do that? How do I constrain this? So what I'm going to propose now is, as I build on this expression, I'm going to add a constraint here. And I don't have space here, but I'm going to write at the bottom here, I'm going to add a constraint where everything in yellow must occur and everything in this green that I'm going to propose should also occur. But what I know from this picture is that if it should be exactly two same systems, let's give this a name. Let's not use the word x. I'm already using x there. So let's call this C. Let's call this C and let's call this D here. I can see from the picture that for C and for D, they do not monitor every single remote server. I mean, it's the picture is telling you. The picture is telling you that look at me and see that C and D does not monitor exactly every single remote server. Okay, so how do I put this here? Well, I'm going to say over here that again, now looking at this entire domain in pink here, and for all z, for all z, but z is being pulled from this domain of systems such that z is not equal to x. Okay, it's important that whatever element I choose from this pink domain, it should be different from A and B, because I know A and B are monitoring every single remote server. I really want from this domain only those systems that do not monitor. So this Z has to be different from X, and Z has to be different from Y. Okay, if I can guarantee that they're different, I also know at this point that the monitoring of C on S shouldn't exist. Okay, this piece over here. Okay, so let's do it this way. This piece over here shouldn't happen, right? There is no such thing that will occur. Okay, so for all z's, as long as z does not equal to x and z doesn't equal to y, the monitoring will never ever happen. Okay, so this will guarantee that you have every remote server is being monitored by exactly the two same systems.